Well, here we go. I want to welcome you to the 122 Python course. And we're now in the second week, and I wanted to just discuss a little bit of Python with you and encourage you to ask questions and also encourage you to keep up with the assignments. It is really easy to get behind, and it's really hard to get caught up. So this little particular example is going to demonstrate something that I want you to start thinking about. It's very easy to write Python code in the examples from your textbooks that is not inside of a function. And so let me just give you a quick example of that. Let's say I wanted to input some numbers and just output the product of those two numbers. Very simple. And I'll keep it to integers. So I'm going to go ahead and just do a real simple example of inputting an integer. And I'm going to put a little prompt here. And notice how I'm converting the input to an int. And I'll do this a second time. So we're going to get two numbers here. Notice the little space after the question mark there. That simply makes it look better when it prompts you. So now let's just go ahead and print the result of that. And I'll put a little output string. So let's say the result of x times y is, comma, and then x times y. Now, this shows a use of the comma separating two items I'm printing here. I'm printing the string, comma, and then the integer result of multiplying the two numbers together. The comma is going to insert a string, a space into the output right after the word is, so I don't need to put another space inside that string. So let's see if this works. Now again, I might have an error in this. When I run it, I'll get an error message, but I'm going to go ahead and hit the run button. And it asks me down at the bottom, you know, it's for a number, and I'll just put in some number. And I'll put in another number, and it tells me the result is 68. So I get this very simple input and output. So this is a nice simple example of a Python program that runs one line at a time. The lines 1 through 3 you see there are just a comment. The triple quotes comments are typical for a comment at the top of your program. And then the lines just execute one after another, line 4, line 5, and line 6, and so on. It's kind of a very natural thing. Now I want to show you another approach, though, that I want you to start considering with all your code. And this approach basically introduces the simple idea of a function. A function is just a small unit of code that is given a name. Now, almost all programs written today are composed of literally hundreds, if not thousands, of functions. And almost all code exists inside functions. So I really want you to start thinking about this. It's a very simple matter to convert this piece of code into a function. We just define def, our function name. So I'll just call this sample1. And then we have parameter list, and that's just indicated in this case by the open and close parentheses. And then a colon to end the heading of our function. And then we simply put statements into the body of our function to, have the code that we want to execute. So in this particular case, I just want these statements at lines 6, 7, and 8 to belong to this function. And the way I indicate that is I use one indentation level on my statements in the body of my function. And this indicates that these statements, 6 through 8, now belong to this function. So if I run this program right now, all it will do is define this function, sample1, and it associates that name with these three statements. But that's all it'll do. It's like an assignment. It assigns this body to that name. And that's all it does. It doesn't actually execute this block of code. So I'm going to hit run right now, and we'll take a look down at the bottom and see what the output is. You notice it says run first sample and nothing in the output. So at this point, how do I actually get that function to run is by simply calling it and giving it its name. So sample1, that's the name that's associated with that block of code, and I need to tell it to actually execute that block of code, and I do that with the function execution operator. So that set of parentheses right there basically says run the function that has the name to the left of the parentheses. So now when I run this, let's see what happens. It prompts me for a number, prompts me for another number, and then prints the output. So this type of programming where you put your code into a function is essentially what everyone does. And so when they first introduce programming in most textbooks, they don't just go straight to that. They talk a little bit more about some of the basic ideas. So let me demonstrate again this idea, but put it inside of a function. So I could say something like function, and I'll call it basic ideas. And we can demonstrate the use of a print statement to print things. So I could say, print hello world. That's a very simple thing that almost all books seem to start with. So this is how I do output to the screen. So just printing to the screen, hello world, easy as can be. I could print multiple things, of course, if I wanted to, simply by separating them with commas. This is an example of printing out a string cat, a string dog, an integer value 10, and a floating point value 3,432.444. Pretty simple idea. Now, at this point, if I want to run that program, I need to just give it the name, basic ideas, and then, of course, the parentheses to call the function. Let's go ahead and run it. As you would expect, it should just run those two print statements. I'll go ahead and do that. And there it is, and notice how it printed out those values, separated by a space. Remember, the comma in the print statement will output a space in your output. So those commas you see there are why I'm getting spaces in my output window down below. Let's go ahead and clear that output window. I'll just right-click on that output window in Thonny, hit clear, and we start with a fresh output. Let's go ahead and add a few more basic ideas here. Another obvious basic idea that they introduce early in most textbooks is the idea of a variable that essentially represents a value in your program. So let's say that I want to have an integer 100 in my program, but I would like it to be referred to by a name. So let's just go do something simple. I'll give the name x, and then I assign the x name to the object 100, and I do that with the equal symbol. Notice the spaces around the equal symbol there, that's for readability. It's not required, but I ask you to think about the readability of your programs and therefore use spaces around the equals assignment operation. Now I want you to think very carefully about what I just did there. What I did is I introduced this object 100, and 100 is an object in Python. It's an integer object, a whole number. And what I essentially did was I put a label on that. And I'm going to demonstrate this by saying, well, what if I say something like y is set to x? So at this point, I still have simply just the object 100, but it actually has two labels on it now, x and y. And you can think of those labels as though they're like sticky notes. And so you've got this object, and you should try to build this model in your brain that that value 100 is an object. The x and y, those are simply labels in your program for objects. Another example might be something like this. I now have another label in my program called name. That label, think sticky note, is stuck on a string object. In this case, the string object is Bob. So again, in your mind, you should kind of start thinking of these things as real objects that you could touch. So you've got this string sitting there in your living room. You could see it. You can then stick a sticky note on it. And indeed, in this case, that sticky note would be name. Now I can print these, of course, just by saying print x, comma y, comma name. And you'll expect, of course, that it's going to print out 100 for the x. And what might you think it's going to print for the y? Now remember what you're thinking. You've got this object 100. It has two sticky notes sitting on it. So when I come down here and I print the x, of course, I get the 100. And you get to think about what the y is going to print. And then name is the sticky note that's on this string object. So it's pretty easy, I think, for most of you to figure out what that's going to do. So now when I run this, let's go ahead and run it. Indeed, it printed 100 both times and the bob. Now let's throw a little bit of a curveball at that. What if I now say something like x is 200? Now how would you think about line 16? Well, line 16 introduces a new object into my program. In this case, the new object is the integer value 200. And what I've essentially done there is not introduced a new X label. I didn't make a new sticky note. I already had the X sticky note. So I basically have removed it from the 100 object, and I've taken that X sticky note and I've stuck it onto the 200 object. And so now when I run the program X and Y, I bet you can imagine what my output's going to be. Let's run that. And indeed, the X was on the new object, the 200 object, and it printed the 200. The Y is still a sticky note on the 100 object, and indeed it printed what you would expect. Now what would happen if I come down here and I say again Y is set equal to X? What change does that make in my program? Well, what it's basically saying, again, is, well, think about X. What is it? It's a sticky note on this object 200. And now I'm essentially saying that Y is set to the same thing as X. So that means that Y is now moved off of the 100 object and is moved on to the 200 object. And so when I run this, as you would expect, we get 200, 200, and Bob. Now some of you might be wondering what happened to the 100 object. Again, if you're imagining that these objects are sprinkled around, maybe in the room you're sitting in, then you're like, okay, I had a 100 object and X was stuck on it. Then I put the Y on that 100 object. That's cool. I put name on the string Bob. All right. And I can see these things in my mind's eye in my room. I create a brand new object, 200, and I move the X sticky note over to the 200. So now I've got three things in my room, a 100, a string Bob, a 200 object, and I've got them all labeled. The X on the 100, the Y, the X is on the 200 now. The Y is still on the 100, and the name is on Bob. Okay, that's my vision. And then I come over here and I say, Y is set to what is the X. Well, the X label is where? Well, the X label is on the 200, so now the Y is on the 200. What happened to the 100? Well, in the Python world that you're living in for this term, that 100 object no longer has a sticky note on it. The sticky note name is on Bob. The X and the Y are both on the 200. The 100 doesn't have a sticky note on it. And when an object in Python does not have a sticky note on it any longer, it disappears. Poof! It's a little bit like magic. Now don't worry about why that's happening or actually how that takes place, but just know that's how Python works. And if anybody tells you otherwise, you should ignore them. There are a lot of people out there on the internet that describe variables incorrectly when they're talking about Python. And it's different from other languages. Some languages work similar to this, but many languages do not do this. And so if you're familiar with another programming language, like C, for instance, then C is a very different programming language. It doesn't do this. So the 100 is just gone. And there's no way you can get back to it, unless, of course, you introduce another 100 in your program. So here I can say is set equal to this 100 object again, and now I've introduced another 100 object. All right? Now, technically, under the covers, Python does kind of a tricky little thing, but this is not something for you to worry about or even think about. The Python programming world, basically, when you start the Python programming language, when you say run, the Python world actually includes a whole bunch of these integers. Actually, it includes a little over 200 of these integers. I'm not sure exactly what the range is. Maybe, it could be from 0 to 250 or so. But the range includes, not quite 300 values. And they exist all the time. And so when I do this statement right here, I just stick that sticky note X onto that object. And it already exists. But that's simply for an efficiency's sake. If I do something like y is set equal to 1,000, well, that 1,000 object didn't exist. And now it does. And y is stuck on that 1,000 object. Of course, when I run this, we should see that in the output. There it is, the 200, the 1,000, the bob. And if I actually then did another statement after this and said y is set equal to, the label y is stuck onto 0, well, now the label y is stuck onto a 0. Well, that 0 object already did exist. It's just sitting out there waiting for me to stick a sticky note on it. But this 1,000 object, it's not one of these magical numbers that already exist. And again, most Python books will not even tell you about this magical fact that a small number of the ints in the world already exist in the Python world. But that 1,000 at line 20, because y sticky note gets moved to a 0, the 1,000 goes away. It's gone. And if you want it back, you'd have to create a brand new one. Okay, so we've now seen this little discussion of variables, and I can come back to that at any time, and I actually have a number of things in our assignments to have you really think about what I'm talking about with this notion of labels on objects. This is the way to think about variables. The label X is attached to that object 1,000. So on the left-hand side of the assignment, that's a label. The object it's attached to is on the right. And that's true also. What if I said something like this? What if I said Z is set equal to X plus Y? Well, X plus Y, you'd have to say to yourself, well, what's X plus Y at line 21? Well, we can go back and look and see what the very latest sticky note move is for the X, and the X was stuck on that 200 right there at line 16. And the Y, the latest one here, the Y sticky note was moved to the 0. Let's add something else to this. How about plus 1? Well, in this case, we evaluate this mathematical expression, and we get 200 plus 0 plus 1, which essentially effectively gives me, of course, the value 201. Now that happens to be one of those magic values that exists. But Z is now stuck on that particular object. So the Z note is stuck on 201. And so if I printed Z, of course, I should see 201. And if I don't see 201, I'm really pretty confused by that. Let me also put a little descriptive label there so that when I see my output, I know what it is I'm looking at, my output. So I'll say Z is, and with the comma in there. Notice there's no space after the word is, because I know that comma is going to give me a space. All right, let's run that. And Z is 201, just like we thought. Okay, that's pretty cool. So I'm going to finish here with just this little introduction. The big idea, two big ideas in this example then are, the ideas are I should put all my code into a function. Even if I want to test out just one thing, I could put it into a function. Let's just do a real quick example then. Def one thing, open close parentheses, colon. I'm always forgetting to put the colon after that. Yeah, there it is. Let me show you one idea. I can say print And I could say, how about I want to print ha? I want to laugh. I want to laugh a whole bunch, right? So I'll do ha and a space, and then I'll say times 10. Now this is a little bit funky to see for the first time, but basically what I'm saying is take that string, including the space inside the quotes there, take that string and multiply it times 10. All right. Well, let's see what that's going to do. Now, to actually see that function do its thing, I need to call the function, put the name of the function, open close parentheses, and it'll now call that function. I'm still calling the basic ideas function, of course, so it's going to run that one first, then it'll run this one. All right, let's run that program, see what it does. And there's the output from the first function, and there's the output from the second function. But again, notice my program statements are all defined within functions, except for these two that call it. Now, many programmers would actually take that one step further, and they'd say, I want to define a main function, and then they would put all of their other function calls, I'll chop that out of there, and they would put all of those in main, and now then, when they want to run this program that might have many functions, they simply call what? What function do I want to call to see everything happen? Well, of course, it's main. So now I can call main. Let's clear this output window with a right click. Now when I run my program, it will define 4 functions. It'll define that function, sample 1, basic ideas. It'll define the one thing function, and it defines the main function. Now when I call the main function, of course, it then in turn calls basic ideas, and it runs that, and then it calls one thing. Notice I didn't call sample 1, but I could put all 3 of them if I wanted to in there. Let's go ahead and put all 3 of them in there. I'll call sample 1, and now my main will run all of them. Let's try it. There's sample 1 asking me for a couple of numbers. It puts the result, then it runs basic ideas, then it runs the one thing function, and I see all my output. Now, why am I emphasizing this notion of using functions? Because your programs, as we go forward, will be all functions. And it's just a matter of the order of introducing these ideas. And many textbooks don't introduce functions early on in the game. They should. If I wrote a textbook, I would. There's a topic we won't discuss in this class called object-oriented programming using classes. And many modern textbooks start with introducing classes, then they introduce functions within the classes, and they also then start talking about the basics. So this is a good way to start thinking about breaking your program into smaller pieces. And in fact, almost all programs written today are made up of many, many functions that have a small number of statements. This function right here, it has about as many statements as I would ever expect you should put into a program. In other words, break your programs into small units of code, logical units of code that do one thing well, and those functions should be relatively short. I basically tell students that your function shouldn't be any longer than 10 lines of code in each function. So start thinking about that. You got a 10,000 line program and you only use 10 lines per function. How many functions will that program have? Well, 10,000 lines of code divided by 10, that's 1,000 functions in a 10,000 line program. And by the way, a 10,000 line program is a small program. We will only be working with small programs, but you still want to start developing proper programming habits. And proper programming habits, you put your code into functions. This last example is a little bit advanced because we have a function that calls functions. Well, that's very, very common in a program. Okay, I'm going to stop with this. I encourage you to ask questions at every step of the way. Do not hesitate. Send me email. I will get back to you. My grader's looking at what you're doing. I encourage you to do the homework. That's a very important thing if you expect to pass the course. So please let me know if you have any questions.